So I mentioned that we were going to do sort of a step-by-step to actually securing your MongoDB instance, MongoS instances, etc. So let's just go through those. Some of these we'll dive into in more detail, others will be for later lessons where we can actually explore them in the depth that's required. The first thing is to turn authentication on. And that was covered in M102. It hasn't gotten much more complicated since. There are some options that become available when we expand that to include SSL. So we'll talk about those. Those have been added since M102 was recorded, and we didn't go into SSL in M102. So first of all, though, you turn authentication on, and you add users with appropriate authorization. So if a user only requires read access to a single database, that's all they should get. If you are adding a super user, someone who needs to be able to administer and do everything on this system, that's a completely different situation. So you need to add users with appropriate authorization. And actually, as a sub item here, you generally want to add a user admin first. And actually, this is documented pretty well in the security documents. So I'm going to go reference those, as I mentioned I was going to do earlier. So here are the excellent security documents, docs.mongodb.org/manual/security. And although you can get all of the documents in PDF and other formats, EPUB, for example, the way we publish allows us to do that. We specifically call out the fact that you can download this section in PDF form as MongoDB security, and here's the link to it. A lot of people like to have this as reference material. It can be easier to go through in a more static environment than linked HTML pages. But a lot of this will be very familiar to you if you've gone through M102, which is the prerequisite to this course. Enabling talks about role-based access control. We're going to get into that in a second. Authorization, auditing, and encryption. We're going to talk about all of those things. And it really does have an excellent series of tutorials here. A checklist that you should check through to make sure that you've actually considered everything on there as relevant to your environment. Tutorials, user and role management, and even then at the bottom, vulnerability reports. If you do find a security problem in MongoDB, it can be reported, and other reference material there. So certainly a recommended thing to look at. So I mentioned adding a user administrator, and in this tutorial about enabling authentication, you can actually see that it says if you create the user administrator before enabling access control, you will disable the localhost exception, as we discussed. There's also a full procedure then for the recommended way to actually add a user. Key files we're going to talk about in a second, so we'll come back to that. Creating the system user administrator even gives you a sample user password and shows you what the role should look like. So you can copy and paste this, change a couple of fields, and you've got your user just as you needed. So add a user with the appropriate authorization, add a user administrator first. The next thing you're going to want to make sure of is that the hosts themselves, the MongoDB instances and MongoS's, are using auth. And this is covered by Dwight again. The option here is the key file, sort of like a shared secret. Again, the one caveat, this usually has to have 600 permissions, restricted permissions to the owner only on a Linux system. So chmod 600 is the one there, again covered by Dwight in 102. So they use the key file to authenticate internally with each other and prove that they are valid members of a set. So the key file being identical and consistent across all members of a particular set or cluster is paramount. In 2.6, with the additions we've made to SSL functionality, there is now an alternative to key file, and that's X509 certs. We're going to be covering them in depth in a later module, so I'm not going to cover them here, but they are an alternative to key file that's been added, and a vastly more secure alternative as well. I'm calling this out explicitly: configure roles, appropriate roles for users. This essentially ties into this same thing here. You want users to have the appropriate level of access, but no more. Just best practices when doing it in general. And then another one here, which is really the only network-related option in MongoDB, besides the port that it runs on, things like that, and that is bind IP. Bind IP sets the IP address that MongoDB and MongoS listen on. And so locking this down to a particular IP address can make things far more secure. That deserves a better explanation. So let's just draw that out for a second. Let's say that this box represents a system, and it doesn't really matter if it's Linux or Windows or anything else for that matter. And let's say that I'm going to use the Linux nomenclature regardless, because it's the one I'm most familiar with. Let's say that this is ETH0, which is a physical NIC, the first physical NIC detected by the operating system, and this is ETH1, the second one. and this is a logical diagram only, of course, not physically related to anything. And we'll call this one the loopback, LO, in Linux parlance, and it is 127.0.0.1. So this is the localhost exception that we mentioned before, the loopback address. So this is the one that you're going to be connecting on if you're connecting internally. You connect through here, you get the localhost exception, which allows you to add your initial user, etc. So you've got a MongoD process, or MongoS, but we'll just keep it at MongoD for now, living on this system. And given what we've called it, it's a Linux system. So there we go. So it's a Linux system. You've got these various interfaces. You start MongoD, and if you don't specify something in bind IP, what it will actually do is listen on all interfaces. Okay, so we've already given this one an IP address, 127.0.0.1. That's the default. Let's just say that ETH0 is actually our internal facing interface on this machine, and this has a 10.0.0.1 address. And ETH1 here is an externally facing IP address that goes out to the internet at large, right? So this is going out to the, the internet here, whereas this is an internal network. It doesn't really matter what IP address we give this, but we could say 8.8.8.8, the Google public DNS server. So by default, you start up MongoD, it listens on all of them. If you attempt to connect on, say it's the default port 27017 on any of these interfaces, it will answer you. Right, and then of course you'll have to prove you are who you say you are if you have authentication turned on, etc. And why is that potentially dangerous? Well, if there's no firewall in place or anything else, this is a publicly accessible IP address. One of the more common ways this gets exposed is, say, in a cloud service such as EC2 or one of the other, Google Compute Engine, whatever it is, where you've bound to a public IP address, and then essentially the entire world can see your MongoDB port 27017 and connect to it, right? It's not locked down in any way, shape, or form. And you can see why that might be dangerous, right? Particularly if you haven't gotten around to adding users yet, someone finds your MongoDB database and starts, inserting and adding their own users or doing other things to it, or reading your data that you wanted to keep private. So if you instead set bind IP equal to 10.0.0.1, then you get rid of the listening here. MongoD will no longer listen on that interface. So if a request comes in on port 27017, it gets connection refused, nothing happens. And in fact, because we've only specified 10.0.0.1, we've essentially removed localhost access. So if anyone was connecting to this host locally, you'd want to make sure that they connected to this IP address, so they wouldn't actually be able to connect. So there you go. That's one way you could have secured it, 10.0.0.1 only. So you would definitely have to make sure that. A more common way is to do your internal IP address and 127.0.0.1. And you can specify 2 or 3 IP addresses that way, just comma separated. So now you're listening on both interfaces again. You can talk locally, so if someone fires up a connection to localhost, it will answer it. And if someone on your internal LAN fires in a connection this way, it will also answer it. Okay? Now, what if we did it the other way around? What if we only specified 127.0.0.1? Well, that's an immediate problem, right? Now the only thing that can talk to this MongoD is other things on this host. Now that might be fine if you've got another, MongoD here, you're running, for test purposes, and you're going to have these really only communicating with each other. So it's essentially just a loop back, hence the name, right? So it goes out here and loops back in again and connects and everything works. But if you put a MongoD anywhere else, internally, externally, anything. So say there's another MongoD over here living on the internal LAN. There it is. If it attempts to address 127.0.0.1, it'll talk to itself, right? It's a loop back address. You try to talk to that, it goes right back in, right? So there is then no way for anything externally to talk to this MongoD process, and you can't do things like replication, right? You can't have it be part of a sharded cluster. You can't have it do replication. It's just not going to work. It's going to fundamentally break how this MongoD works. It's very secure. Only things on this host can actually talk to it, but it also completely breaks its distributed nature. Okay, so if you do lock it down to 127.0.0.1, only things on the local host will be able to talk to it, and you have to be aware of that. There are a couple of ways around things like this, but generally that is going to be the case. So be very careful with how you use bind IP. You can have unintended consequences, and make sure that whatever address it is that your other MongoDs and MongoSs and config servers and clients and applications use to talk to this MongoD, that you are actually listening to it. So Generally, you're not going to want to just bind things to 127.0.0.1. And as I mentioned, I'm using 2.6.1, which I've compiled myself with scons-ssl all and installed it in this directory. And here's my config file for the first MongoDB that I'm going to start up. This will be our primary to start with, and we're going to use this to, initiate the replica set and then add new members. So, what have I done? I'm going straight to require SSL first of all. Authentication is true. This is basically a very expanded one. You may have seen a similar one earlier. And the key pieces that I've added, first of all, SSL mode is require SSL. SSL PEM key file, this is the server cert. For the cluster file, I'm going to use the server cert as well. Usually, these would not be the same thing, but it is the case that the server will actually default to using the server cert if you don't specify your cluster file. So I'm being a little bit specific here just to show you that it is an extra option. The cluster file is what the server is going to use to prove to other MongoDBs and other MongoS's, if it was a sharded cluster, etc., that it is actually who it says it is. Right. So this is what it will be using in place of key file. So this line here is what replaces the old key file parameter, and this will be your X509 cert. This here is the server cert, which is then used to validate the clients and everything else. So they're two separate things, but in this case they're going to be the same. This is because I'm running in a somewhat contrived environment. Everything's on the same host. I didn't want to go creating tons and tons of certs, so that's why they're all the same. So you might be slightly different in production, but and then the SSL CA file, your certificate of authority file. This is basically what's been used to verify the server and what would be then used to verify any incoming X509 certs and or any incoming server certs for the cluster file. So very important there as well. Cluster auth mode I've set to X509. And then the rest are all pretty standard stuff. I'm just using small files, no journal and uplog size, just to save some disk space on this fairly limited VM. Now that the SSL enabled and requiring SSL instance has actually been started, and we haven't added any users to it yet, of course, it is blank. So it should be sitting there waiting for rs.initiate and then for us to actually add users, which we can do still via the localhost exception. We just have to connect with SSL first. So I'm going to connect with SSL here, and let's do that. There we go, successfully connected. And if we run rs.status, we can see we're on test server, we're on the primary, and we've got a working replica set, but of course we haven't actually added any users. Now we could add regular users here, and we could connect and authenticate with those and use a standard challenge response, users and passwords, but we have a better option now. We have the option instead to use X509 certs. So what we're going to do is add a user. It's going to look a little different than our normal users, and the reason for that is that we're going to be using this external database. We're going to run a command against it. So db.get sibling db $external, and we're going to run this command called create user. So it's not too dissimilar to creating a normal user. However, this is a very odd username, you might think. Well, this is the subject line from the cert, the X509 cert, that we're actually going to be using to authenticate. You saw me connecting with it. I just had it in the command line for the Mongo shell a little while ago. It's not actually being used, it's just signing in. It's not actively being used to authenticate in that case. So it's that same cert, and I'll show you how to extract this line. You can either just cat the whole file, scroll up and have a look at the subject line, or you can run an OpenSSL command, which is in our documentation as well for how to do this. We're going to give this user read-write access on database test and have them as a user admin any database on the admin database. And as we covered earlier on, we were talking about roles and authorization. This gives you indirect super user access. So what we'll actually do in a minute is use that to modify this user and things like that. But that's what we're doing here. Down here you can specify your right concern. I'm giving you sort of the best practices version of this, W majority with a timeout. We only have a primary, so it's going to be pretty simple to satisfy the W majority in that case. So let's do that. OK, 1. If you go use $external show users, I can't actually do it because I don't have sufficient privileges to actually show it. However, I can alter the user. So let's do that. Let's do it so that we can actually see everything that we want to see. And for that, I'm going to do something that you should only do with great care. I am going to grant that user the root role. So if you like, I was just giving you the quick look at best practices, you should then limit the scope of the users that you're going to add from that point on and only give them the permissions that they require. But just so I don't run into any other nasty little things where I didn't give myself permission to run a particular command, I'm going to make myself a super user. So, and I failed on this one as well. Actually, I know why that is. It's because I haven't actually authenticated. So let me authenticate first. So I'm going to use the same get sibling DB call, external. I'm going to auth against it. I'm going to use the mechanism MongoDB-X509. And the user is that same user that I added earlier on. Now the fact that I've already connected with this shell using the correct client cert means I don't have to disconnect, reconnect, and specify that cert. So this is a handy little shortcut here. So I've authenticated as that user, and I should now be able to alter the user. Now, if everything has gone to plan, my previous test should now work. Use external, show users, there we go. So now that after you've authenticated and updated the user, we can switch to external and run the show users command. And here you can see it, external dot, and then here's our username. That's the ID it's given, and then the user itself. So there's the roles, and as you can see, I now have the super user root role against the admin database. So essentially have the root role globally at this point. So let's break out of this, and I've created a couple of other very, very similar config files. So let's have a quick look at those. This is going to be another instance that I run on 27020, hence the numbers. And again, very similar. I just have a commented out line from a legacy. This is one of the 2.4 options that's no longer used. All the rest of the thing should look very, very similar here. So it's really just the ports and the paths that have been changed from the primary. So we started our first secondary. Let's start the second one. Let's go back, and once again, we're going to connect with SSL and use our client cert. This is our X509 cert that we mentioned earlier on. We're going to connect with that. We haven't authenticated yet. We logged out and logged back in, so we're not authenticated yet, so we don't have the permissions to see the startup warnings. We're not currently logged in as a user. So let's quickly log in again using our same command from before. There we go. Our status, as you can see, is still the same as it was previously. No big changes there. Let's add this node. So let's add our two new nodes. Test server 27020. Let's add that one. That's okay. Let's add 27022. That's okay as well. They're in startup 2 at the moment. That should alter very, very soon. They should be in secondary momentarily. There's no actual data on these hosts. So, yep, there we go. They've both transitioned to secondary now. And essentially what we have now is these two new ones are authenticating as __ system and using their server certificates, their cluster files, but the same certificate as the server because we didn't specify a different one, using their server certs to authenticate with each other and no longer using a key file. The benefit, again, as I mentioned, is that they can be validated and revoked as needed. We have support for certificate revocation lists, or CRLs. So a much more secure setup now. The communication between these hosts will be SSL encrypted, and as we mentioned earlier, also compressed. So you can't sniff it, you can't see it on like a TCP dump or a packet capture unless you happen to have the certs to allow you to decode it, of course. And an overall much more robust, from a security perspective, configuration. Now the one last thing I mentioned I was going to do was show you how to determine what the subject line was of a particular cert. So we're going to do it with the client cert that we were using when we were connecting with the shell. And this command is, you can get it from the OpenSSL man pages obviously, but it's also included in our own documentation as part of the tutorial to configure X509. So this is included there. Let's take a quick look at the output. And I'm just going to pipe this into head so I'm not printing out the whole cert that we're using here just in case that it gets reused. It's only for QA purposes, so it shouldn't really matter, but just security best practice, I'm just going to pipe it into head-5 so only the top is seen. It's the only part that you actually need. So you get the subject line here. CN is test client, and the OU is QA client, O is MongoDB, ST is California, C is US. Let's do the same thing for the server one that we just used, or we just used for as the cluster file. And you can see the CN is changed, test server instead of test client, right? The organizational unit is QA instead of QA client, and the rest is the same. So when the servers are checking to see whether this is a valid user and a valid cert to be using for X509 authentication for the internal system processes, they're going to compare this whole subject line here. And if they're equivalent, then they'll accept it. You'll use X509 certification, and off you go. On this side, for the client end of things, the CN is expected to be able to change, right? So the changes is your host name. This is going to change quite a bit. For the test server, you need to have more of this the same. Again, all of this is documented pretty well in the tutorial. It lays out exactly what needs to be comparable in the certs.